Unit prefixes are a way to simplify the speaking or writing of very large or very small numbers. Even when we use scientific notation to write those numbers more compactly, scientific notation still doesn't exactly roll off the tongue, and so we can use unit prefixes to simplify the way that we write or say those numbers. You need to know your unit prefixes. You need to know all of these from -15 to 15. You need to know the name and also the symbol associated with each unit prefix. And basically what these do is when you have a exponent, a power of 10 in your scientific notation, you have 10 to the 12 or 10 to the -6 or what have you, replaces the power of 10 that you have in scientific notation. What you're going to do is you take the number that you have in scientific notation, something like what we have here. We could rewrite this in scientific notation. Notice that this becomes 10 to the -4. And so if you have 10 to the -4, that falls between 10 to the -3 and 10 to the -6. So there's two different unit prefixes you could use. 10 to the -4 could be milli with a lowercase m, or micro with a lowercase Greek mu. And then you'd simplify the rest of the number for compactness. Notice also when you use unit prefixes, you keep the significant figures that you had in the original number, and you make sure that you have the same significant figures at the end. These values here should be between 999 and 0.01. Basically, each power of 10 goes by 10 to the 3 or 1,000, and so we're keeping our value here in the hundreds and hundredths range, so that we're not more than 1,000 above or below, so that we have these two different unit prefixes on either side. Let's see a couple examples of those. Here we have a very, very small number with a lot of decimal places. And so we could rewrite this in scientific notation and convert that to a unit prefix. It's a little easier to just count it directly. This we know that the unit prefixes go by powers of 10, and the powers of 10 represent, each decimal place represents a power of 10. So this would be 10 to the -3, 10 to the -6, 10 to the -9, and 10 to the -12. So my two possible places to put my decimal point would either be here, and in that case, I would have 0.04100. 10 to the -9 would be nanometers. Whatever unit I have here stays there. The little n there represents the 10 to the -9 that I have. I've got decimal 041, and then these are still significant zeros, and so I have to keep my significant digits there as well. I could also put my decimal point over here. That would be 10 to the -12, and so I could have 41.00, and 10 to the -12 is pico. You would use picometers in that case. Same idea here. I have my decimal point here. I have my significant figures over here. These are my significant figures I want to hold on to. So I could move my decimal point there, and this is -3. Or I could move it, I've got 1, 2 decimal places. I don't have a third, but I could always implicitly put more zeros there. They don't really exist, but I can pretend like they're there, and this would be -6. So either I put my decimal point here, 0.37, and 10 to the -3, those are milliwatts, or I could put my decimal point over here, and I would have 370, and 10 to the -6 is a lowercase Greek mu for microwatts. A watt is a unit of power, or how much energy is delivered per time. But to be honest, at this point, we don't care what the unit is. Whatever unit our measurement has, that unit stays there, and the prefix gets tacked on to whatever unit symbol is already there. Notice here that these zeros were just sort of added. They were implicit to us, but we had only 2 significant figures, and so we have 2 significant figures there and 2 significant figures there. This 0 is not significant, so we kept the correct number of significant figures. We can do the same thing if we have a very large number. Again, we want to keep our significant figures only. In this case, we have a implicit decimal point. Implicitly, it's at the end of the number if it's not written directly. And so we can go, here's 3, here's 6, there's 9. We can't keep going because we ran out of decimal places, but we can implicitly throw in a few more zeros here. And so if I go here to 12, those are my 2 powers of 10, my 2 prefixes I could use around my significant values. I could put my decimal point here, basically, which would give me 60, and then that would be gigajoules. Or if I put my decimal point over here with my 10 to the 12, that would be 0.06, and that would be petajoules. Notice that I had only 1 significant figure, and so I rewrote both of these, so I had only 1 significant figure in each time, in each case. These zeros we said were implicitly there. It doesn't count as a significant figure, and so we have already made sure that we have the right number of significant figures at the end. Lastly, we have volts, and notice here we have the vertical bar. We mentioned that the vertical bar tells us that that is a significant figure. It's a significant 0. We measured it, and we measured to find that it was exactly 0. So that's how we can call out a value and make sure that we are claiming it as a significant digit. Again, there's a implicit decimal point here. I could move 3 places. I don't have enough decimal points here to move another 3, but there are implicit zeros, and so I can move over here to 6 places. So if my decimal point is here, that would give me 56.0, and 10 to the 3 is kilovolts. Or I could go all the way over here, and this would be 0.0560. I have to go 560. I have to keep a significant 0 here because I have a significant 0 there, and 10 to the 6 is mega, and so this would be megavolts. And so whenever you have a number like this, a very large number or a very small number, you are trying to move the decimal point in either an explicit decimal point or an implicit decimal point. You're trying to move it into the vicinity of your significant digit. So basically, the numbers that you would keep should be somewhere less than 1,000 and greater than 0.01, less than 1,000 and greater than 0.01. You can move your decimal point to either side of those significant digits to have a larger number of a smaller unit or a smaller number of a larger unit. A lot of times for a specific application, you will have a preferred unit prefix that's just used by convention.